Hello, everyone. Thank you, Caroline, for your introduction. So I'm Enrico. I work in the Linux streaming team, and I'm going to talk to you about JMS API and Apache Pulsar. I will describe briefly what is Java messaging system and how you can use it with Pulsar. We will also see why you should take a look to Pulsar if you are running a Java Enterprise application or you are running with JMS. We will see how to map Pulsar with the JMS model. We will see some code examples of Java code with the JMS API, and we will have a live demo using Apache TomEE and Enterprise Java Beans. What is it? Java Messaging API. Java Messaging API is like JDBC. With JDBC, you can connect to any SQL database that has a JDBC driver, and you can perform queries and access to your data. This is the same thing with JMS. You can connect to any messaging system that supports JMS, and then you can produce and consume messages, you can manage subscriptions, and you can also run transactions. So the core concept of JMS API are very simple. You have destinations, so queues and topics that are sequences of messages. You have messages that contain data, and you have producers and consumers that write to the messages or they read from the destinations. And you have connections and sessions. JMS context in 2.8 API. A connection is a physical connection to the JMS broker, and the session is a sequence of operation on the destinations, usually collected inside a transaction. In the JMS API, we have two kinds of destination. You have the queue, that is a sequence of messages, and each message is received only by one consumer at a time. Only one consumer. And you can browse the contents of the queue and see the list of messages that has not been processed by any consumer. And the topic is similar to a queue, is a destination, it's a container of messages, but you can have multiple subscriptions, so the same message can be dispatched to multiple consumers, groups of consumers, and also messages will be dispatched according to the subscription type. You have several consumer styles. Basically, you have two ways of reading from JMS. You have a receive method in which your application blocks, so the application drives the consumption of the messages, and you have the message listener method, that is the JMS driver calls your application when a message is available. On the producer side, you have a blocking send method in which your application sends the message and waits for the message to be accepted by the broker. And you have an asynchronous send that is available in JMS 2.0 API, in which you pass a completion listener, and asynchronously you are notified of the success or failure of the sending. But in JMS, you don't have any administrative API. So you cannot manage destination, like creating, deleting destination, clearing destinations. There is no API to deal with connection properties. There is no security model, no resource limits, and there is no concept of quality of service, because those features are very specific to every JMS provider. And the JMS API deals only with administered objects that must be provided by the container. We're talking about queues and topics, so destinations, and also the connection factory. The connection factory is the client that allows you to connect this to the broker, and it creates physical connections. When you run your application inside a Java enterprise container, you usually use enterprise Java beans. So you have two big families, session beans, so stateful and stateless session beans that you use in web servlets, when you write web services, or when you code the background tasks. And you have message-driven beans. A message-driven bean is activated by the container when the container receives a message from a connector. A connector is like a JMS system, for instance. And it is the the Java Enterprise container that provides support for lifecycle management. It pulls instances of objects. It connects all of the components with CDI. It coordinates transactions, and in general, it provides you a standard API to interact with the system. And this way, Java Enterprise applications are portable across multiple vendors. But when you want to connect to a JMS system in a Java Enterprise application, you have to deploy a resource adapter. The resource adapter contains the JMS driver. So you deploy the file, you configure the resource adapter, and then you are able to create administered objects, so queues, topics, and also the connection factory. Usually, these objects are bound to a registry, Java naming directory interface registry, but everything is very vendor specific. So each container has its own tools to perform these tasks. We will see with TomEE that this is simply performed by writing a configuration file. So if you are running a Java Enterprise application and probably you are already using JMS, why you should take a look to Pulsar? Because of the blazing performance, you can literally send millions of JMS messages with very low latency, high throughput, and strong durability guarantees. You can horizontally scale every component in the system, and also the storage layer is separate from the broker layer. And you can also move your cold data to an object storage that is cheaper. And due to the multi-tenancy features in Pulsar, you can consolidate many existing JMS applications inside one single Pulsar cluster, because in Pulsar you can isolate your data, your tenants. You can also replay your data. For instance, if you have a bug, you can change the cursor of your subscription back in time, and then you can replay the history and recover from a bug, or you can connect a new version of your application to the production cluster and connect from the beginning of time or from a given retention time. You can replay and see the new version of the application, how it processes the new data. There, you can leverage geo-replication, and so you can deploy your brokers and your application in multiple regions, and you can distribute your data. And for instance, you can achieve lower latency in accessing the data. And also you will be ready for the future, because you can run usual JMS workloads, but you can connect with the other kind of workloads that are available with Pulsar and with modern streaming systems. When you deploy Pulsar, you will have these, usually these are architecture. You have your clients, the producers and consumers applications, and you have the Pulsar cluster that's like a black box, but it contains the brokers, that is the processing, dispatching code. You have the bookies with Apache Bookkeeper. This is the scalable storage. You can scale the brokers and you can scale the bookies totally independently, and you can assign machines to tenants. You will have a metadata service like Apache Bookkeeper, and you probably will have a proxy component, especially if you're running in Kubernetes. You can also deploy Pulsar functions. in order to process data inside Pulsar, inside the same machine of Pulsar. And also you can start I/O connectors that allows you to easily read and write data to other engines or systems like Cassandra, Elasticsearch, or whatever you want, whatever you need. You can connect a third-party object storage, or you can use HDFS to store all the data that are not consumed frequently, but you want to keep your history for the use cases that I told before. And so let's see the core concept in Pulsar. In Pulsar, you have topics and subscriptions. So a topic can be persistent or non-persistent. It can be partitioned or non-partitioned. You don't need to use a partitioned topic to scale out the number of consumers in Pulsar. You have tenants and namespaces that provide logical and physical isolation of resources, because topics are grouped in namespaces, and namespaces are grouped in tenants, and you can select machines or resources and dedicate them to specific tenants. You have fine-grained control over all configuration aspects at system, tenant, namespace, and topic level. So yes, you can really adapt and tailor your system to your situation. And also you can consolidate many different Pulsar-based applications, JMS application in one single cluster and configure each application depending on the needs. You have several subscription modes in Pulsar, especially the key shared mode allows you to spread data among many consumers, but still guaranteeing ordering regarding the ordering key for each message. You have 2 subscription types, and also you have 2 producer modes. So how can Pulsar fit the JMS model? It's very easy, because the JMS topic is a regular Pulsar topic. The JMS queue is a Pulsar topic with only one shared durable subscription. And the JMS message is a simple Pulsar message that has an header and a payload. You have several consumer types in JMS, but you can map them one-on-one with Pulsar subscription types. So this is very easy and straightforward. But one thing that I want to point out is that you don't need any additional system proxy or Pulsar protocol handlers to connect using JMS to Pulsar, because JMS is an API, it's not a protocol, it's not a wire protocol. You can write your application using JMS and you can connect to any existing Pulsar cluster. Let's see how it works. So if you want to connect to Pulsar using JMS, you just have to create a Pulsar connection factory. And then you have the connection factory. This is the standard JMS API. You can create the JMS context, create a reference to a queue. This is not creating the queue, it's creating an object reference to a queue. Then you use the producer, you send the message, and you can consume the message using the standard API. Let's see the code for the live demo. I want to point out a couple of things, then we will run the demo. This is the producer application. We will have a producer application and a consumer application, separate application, 2 separate TomEE instances. The producer is a simple enterprise Java bean that every second writes a message to Pulsar. And in the code of the producer, I want to point out that you have the connection factory and the queue that are provided by the container. So there is no code to create the connection factory or the queue. The administrator will bind these objects to the JNDI registry, and then you can use them from your code. So here there is no code that is about Pulsar. Those annotations have the names that I created on TomEE to bind the connection factory and the queue to the object that I created. On the consumer side, we are using a message-driven bean. So the code is very simple. You just have to provide your callback. You have to provide the name of the destination, and the system administrator will provide a binding between the logical name of the queue and the physical queue. The configuration of TomEE is very straightforward, and you deploy the Pulsar resource adapter, and then you configure it, and you create the queue, the logical queue, and then you map the queue to a physical queue. The name of the queue is foo-queue, and the logical name of the queue is foo-queue that TomEE maps to OpenEJB resource/foo-queue that we saw in the example. So the code for the live demo is on GitHub in my personal GitHub space. I'm going to use Extra Streaming, that is a free pay-as-you-go Pulsar service on the cloud. So I have my topic. The topic is foo-queue, and let's run the demo. I have a script to deploy everything because I don't want to lose time. Here we are installing 2 instances of Apache TomEE. We are building the consumer and the producer applications, and then we deploy them, and we will see the results and the logs. Okay, so in TomEE 2, we have the producer that is sending the messages, and on TomEE 1, we are receiving the messages. So this is working. This is very simple. The code is on GitHub. Let's go back to the presentation. Let's wrap up what we learned. The JMS API is like the JDBC API for databases. So if you write your code against the JMS API, it is very easy to switch to another vendor or to another instance, it's like you do with JDBC. If you want to use JMS inside the Java Enterprise application, you have to deploy the resource adapter, and you have to configure and administer the resource adapter and create your objects. But this is container specific. So we saw how to do this with TomEE. With Payara is another story, and with other vendors it's different way, but the logical steps are always the same. Deploy the resource adapter, configure the administered objects. Very simple. Apache Pulsar is a cloud native messaging system. It brings multi-tenancy and geo-replication as first-class features, and so you can consolidate your applications, and you can move your data to Pulsar easily. You can scale horizontally every component depending on your needs. Pulsar is open source. It is an Apache project. It has a vibrant community. So if you use Pulsar, you're not locked to any vendor. And also it is very easy to switch from Pulsar and from another JMS system to Pulsar, because you just have to switch the drivers and change the mappings. If you want to use Pulsar via JMS, you can use a JMS driver. You can deploy the resource adapter. I'm the author of FastJMS for Apache Pulsar. That is an open source project. It is available on GitHub and on Maven Central. So you can freely use, you can open tickets on GitHub, and you can reach out to me if you have problems. These are my references. So my LinkedIn account, Twitter handle, and you can connect with me on the mailing list or on Slack. You can find Pulsar on GitHub. The same is for FastJMS for Apache Pulsar, and you can read the JMS specification on the web. Thank you very much. Now it's time for question and answers.